So run-free is really exciting for us. So we have gone through major changes in our detector, in our analysis software, in our also the way we analyze the data. We hope to be faster, much more efficient, and to be able to cover all phase spaces many phase spaces that we haven't covered yet. So this is personal excitement for Atlas, but of course run-free will triple our statistics, so it's double the statistics of run-2, and this will mean that we can really increase our sensitivity significantly. In addition, there is a center of mass energy increase, of course, and all of this makes it really important. So let's say that what we are focusing to is to really to broaden our spectrum as much as possible. And this goes in particular, for example, from the fact that we have concentrated a lot on the trigger of the experiment, such that we can improve our performance upstream and that we are not blocked by the initial choices that we make. So we made the choices to lower the thresholds of the trigger, such that we can investigate lower energy of the particles, that we can look at phase spaces that were unexplored to some extent. But we have also done large improvements, for example, in our tracking, aimed at looking for long-lived particles that could, for example, could come from dark matter. We look for tracks that decay not from the primary vertex, but from a displaced vertex. And we have developed a specific tracking that looks for displaced tracks. This is one of the things that we are really focusing to and that we are looking forward for run-3. So I cannot say that where we will find new physics, unfortunately, if we would know, but that's essentially what we are aiming to. So really broadening as much as possible our spectrum and be as general as possible even in interpretations of standard model processes. The Higgs properties, for example, if we search for, if we look at the Higgs properties, that for me will be a milestone of run-3, we can really exploit them with the larger statistics, and we can again not only reduce, increase the precision with which we search for its properties, but also look for again untackled regions of the phase space where we could see new physics. So what we are trying to do is to do a model-independent interpretation of all the deviations also from the Higgs physics to look for new physics. So it's not only searching and learning more from the standard model, but hoping for hints of new physics. And in that respect, for example, we are also the same sort of interpretation that are called effective field theory interpretations. We are doing them also in standard model and in top physics, and one of our aims is to put everything together. So also from that we hope to find new physics, because it will indirectly show up inevitably in these sectors. So this is another way to find for new physics. So if you have heard about the W mass measurement of CDF in the last days, of course, so new physics can come also from standard model measurements, and this is also another way that we are adopting in our research.